This bird weighs less than a smartphone. A tiny Arctic tern hovers above a dark, freezing ocean, its wings beating against the wind. Its body almost weightless against the endless blue. Beneath it, there is no road, no sign, no mountain range, no city light, only water, cloud, storm, and distance. And yet, this small bird knows where it is going. Every year, the Arctic tern travels from the far north of the planet to the far south, from Arctic summer to Antarctic summer, chasing light across the world. Over its lifetime, it may fly the equivalent of 3 round trips to the moon. 3 round trips to the moon. Not with engines. Not with satellites. Not with a map. Not with a compass in its claws. Only instinct. Memory. Stars. Wind. Smell. Magnetism. And a body engineered for endurance. This is not just migration. This is biological GPS. How does a creature so small cross oceans, continents, storms, and deserts, then return to the same nesting place again and again? How does it navigate a featureless ocean for thousands of miles? How does it rest when there is nowhere to land? The answer is one of the greatest miracles in nature. Before the journey begins, the bird must transform. Migration does not start in the sky. It starts inside the body. In the weeks before departure, many migratory birds begin to eat with almost impossible urgency. They build fat reserves, sometimes doubling their body weight. This fat is not ordinary weight. It is fuel, a living battery. Every gram becomes stored energy for the flight ahead. But the transformation goes even deeper. Some birds shrink parts of their internal organs before long flights. The stomach, intestines, and liver can reduce in size to make room for fuel and lower the cost of carrying unnecessary tissue. The body becomes a machine built for one mission: stay airborne. They are burning their own bodies to remain in the sky. Every wing beat spends energy. Every mile consumes the battery. If the calculation is wrong, if the wind shifts, if the fat runs out before land appears, the journey ends in the sea. This is endurance at the edge of death. But fuel alone is not enough. A bird also needs direction. The first tool is the sky itself. Many birds use the stars. Young birds can watch the rotation of the night sky and learn where north is. They are not memorizing constellations the way humans do. They are reading motion. The sky turns, but the pole remains fixed. That fixed point becomes a compass. At night, the stars become a map. By day, the sun takes over. Birds use the position of the sun, but they must also correct for time. The sun moves across the sky. Morning light is not afternoon light. A bird must know not only where the sun is, but what time it is. This means it carries an internal clock. A biological timepiece, precise enough to turn sunlight into geometry, They are not simply seeing light. They are calculating the sky. And when clouds cover the sun and stars vanish, the toolkit continues. Birds may use polarized light, invisible patterns created as sunlight scatters through the atmosphere. Even when the sun is hidden, the sky can carry directional information. Those. It looks like gray cloud. To a bird, it may still contain a navigational signal. But the Earth itself also speaks. Some migratory birds may detect infrasound, low-frequency sound below the range of human hearing. Ocean waves crashing against distant coastlines can produce vibrations that travel hundreds of miles. Mountain ranges, storms, and coastlines all create acoustic signatures. Those. The world may seem silent. To them, the Earth has a voice. The ocean is not empty. It is humming. A coastline is not invisible. It is calling. Then comes the most mysterious system of all, the magnetic sense. Birds can detect Earth's magnetic field. Some evidence suggests they may do this through special light-sensitive proteins in the eye called cryptochromes. These proteins may allow magnetic direction to appear as a kind of visual pattern or overlay, especially under blue light. Imagine flying through fog, darkness, or open ocean, yet still seeing the direction of the planet itself. Not feeling north as an idea, seeing it. A compass written into vision. A map made of invisible force. This is why migration feels almost impossible to us. Birds are not relying on one tool. They are combining many. Stars, sun, polarized light, magnetic fields, smell, sound, wind, landmarks, memory. No single system has to be perfect. Together, they create a navigational network that puts our technology to shame. And then there is sleep. How do you survive a non-stop flight over the ocean when there is no branch, no island, no safe place to rest? The answer is one of the strangest biological hacks in the animal kingdom: unihemispheric, slow-wave sleep. Some birds can rest one half of the brain while the other half remains awake. One eye may close, the other stays open. Half the brain recovers, while the other half continues monitoring the environment. They can sleep and remain alert, rest and navigate, dream and fly. The bird is never fully offline. For an animal crossing open ocean, this can mean survival. Fatigue becomes manageable. Awareness remains active. The sky becomes both road and bedroom. Imagine dreaming while the wind carries you over black water. Imagine resting one side of your mind while the other side keeps reading the stars. This is migration. A state between exhaustion and miracle. Some migrations are so extreme they almost seem fictional. The bar-tailed godwit can fly from Alaska across the Pacific for more than a week without stopping. No food, No water landing. No rest on land. Just continuous flight across open ocean. Its heart pounds. Its lungs pull oxygen with extraordinary efficiency. Its muscles burn fat. And that fat also produces metabolic water, helping the bird survive when there is nothing to drink. Fat becomes fuel. Fuel becomes water. Water becomes survival. Nature still holds records that our machines struggle to match. Other birds use teamwork. Geese and cranes fly in V formations because physics rewards cooperation. Each bird creates air movement that gives lift to the bird behind it. The leader does the hardest work, then eventually drops back so another bird can take the front. It is like drafting in a cycling race. Energy is saved. Distance becomes possible. Survival becomes shared. Migration is not only instinct. It is cooperation. It is timing. It is strategy. Some birds wait at the edge of oceans for the perfect tailwind. They may stand on the shore for days, restless, watching weather systems that we need satellites to understand. Then, when the wind is right, they launch into the dark. There is no turning back. This is the point of no return. If the wind changes, if a storm forms, if they burn too much energy, they may never reach land. Every ocean crossing is a gamble taken by a body that has calculated its chances through millions of years of evolution. The journey is also dangerous because the world has changed around them. Storms can push birds hundreds of miles off course. Predators wait at migration bottlenecks, where tired birds are forced through narrow routes. Cities glow at night, pulling birds away from safe paths. Glass buildings reflect sky and become invisible traps. Light pollution confuses ancient navigation systems that evolved long before human skylines. Our modern world is now one of the greatest obstacles to an ancient instinct. A bird that survived oceans can be defeated by a window. A traveler that crossed continents can be lost in artificial light. This is why understanding migration matters. Once we understand the journey, we understand our responsibility. Turning off unnecessary lights during migration season can save lives. Protecting wetlands protects refueling stations. Restoring coastlines keeps the chain intact. A mudflat, a marsh, or a small island may look ordinary to us. But to migrating birds, it can be a gas station between life and death. If we lose these places, the entire route can collapse. For some birds, stopover sites are critical. Shorebirds may arrive exhausted and immediately begin feeding, putting on weight fast enough to continue the next stage. They do not have extra time. They cannot simply try somewhere else. The migration route is a chain, and every link matters. But when the journey succeeds, the final act may be the most astonishing. Precision landing. After flying thousands of miles, after crossing oceans, deserts, storms, and cities. A bird may return not just to the same country, not just to the same forest, but to the same nesting tree, the same cliff ledge, the same marsh, the same nest box. A global journey ends in a space measured in inches. How? At the final stage, visual memory may take over. Rivers, coastlines, mountain shapes, fields, and human structures become familiar markers. Smell may also guide them. Every valley, forest, shoreline, and nesting area has a chemical signature: salt, mud, pine, water, soil, vegetation. Home has a scent, and the bird follows it. The global map becomes a local memory. The compass becomes a photograph. The flight path becomes a homecoming. A bird lands on the same branch it left months ago. Feathers worn, muscles exhausted, fuel nearly spent. But the mission is complete. Now, the purpose changes. The traveler becomes a parent. The long journey becomes the beginning of the next generation. Chicks hatch. They grow. And soon, some of them will begin the same impossible journey. Sometimes without their parents. In certain species, young birds migrate alone, guided by instructions they did not learn from experience. The map is already inside them. A route written into biology. A direction inherited like blood. This is what makes migration so humbling. We think intelligence must look like planning, language, tools, or technology. But here is intelligence written in cells, muscles, senses, and timing. A bird does not need to know the name of a continent to cross it. It does not need to understand magnetism to use it. It does not need to explain the stars to follow them. It simply goes. And in going, it performs one of the most complex feats in nature. Every migration is an epic saga of endurance and instinct. A story of fat turned into flight, of stars turned into maps, of sleep divided in half, of storms survived, of oceans crossed, of impossible returns. Next time you see a bird resting on a wire, ask yourself, where has it been? Maybe it has crossed a sea. Maybe it has flown through the night. Maybe it has heard the ocean from hundreds of miles away. Maybe it has followed magnetic lines invisible to your eyes. Maybe it is carrying a map older than human civilization. Respect the travelers. They have seen the whole world. The sky is not empty. The sky is a highway. The sky is a memory. The sky is a map. And every bird in flight may be following a road we cannot see.